This video is for Chemistry in the Earth System, Unit 1.5, Tectonic Plate Interactions. Today's essential question: what features in the landscape are associated with tectonic plates? Our first main idea: subduction zone. When an oceanic plate converges with a continental plate, the denser oceanic crust sinks below the continental crust along a unique region called a subduction zone. When oceanic plates converge, the older, denser plate subducts below the plate that is less dense. As the denser plate is subducted, it is recycled back into the mantle. As the oceanic lithosphere slips into the mantle, it rubs against the overriding continental lithosphere. The friction resulting from subduction breaks the subducting plate into smaller pieces. The friction also produces a series of earthquakes that follow the subducting plate into the mantle. Some earthquakes have been recorded at a depth of 700 kilometers. Some of the material from the subducting plate also melts and rises up through the overlying continental crust to form volcanoes. Trench. A trench is a deep valley that outlines a subduction zone. Most trenches on Earth encircle the Pacific Ocean. This region is commonly called the Ring of Fire because it boasts 40,000 kilometers of oceanic trenches, volcanic arcs, and volcanic belts. This region is responsible for 75% of the world's active and dormant volcanoes, as well as 90% of the world's earthquakes. The profile of a trench is an asymmetric V, controlled by the downward moving plate and sediment eroding from the land. As the downward moving plate approaches the subduction zone, it bows upwards, producing the outer trench swell. This slight deformation allows the plate to descend into the mantle. The descending plate forms the outer trench wall. It can take millions of years for oceanic lithosphere to move from the region of the trench swell to the mantle. The overriding plate produces the steep inner trench wall, which is constantly being deformed as the two plates interact. Volcanic arcs. A volcanic arc is a series of volcanoes that form behind an ocean-to-ocean subduction zone. The volcanic islands in an arc are parallel to the subduction zone. Because the subducting plate contains ocean sediments and water that end up in the rising magma, volcanism tends to be more explosive than the volcanism at spreading centers. The Aleutian Islands that extend away from Alaska are a volcanic arc system. The countries of Japan, Tonga, and the Philippines, and the Solomon Islands formed along volcanic arcs. Rift Valley. A rift valley forms between tectonic plates that are moving apart. They are found at spreading centers under the ocean and on continents. Impressive river valleys or deep lakes can be found in some continental rift valleys. The East African Rift Valley is an example of a rift valley where two continental plates are moving apart. Some rift valleys are considered failed and are no longer active. Examples of failed rift valleys converted to river valleys include the Red Sea in eastern Africa, the Rio Grande Rift Valley in southwestern United States and Mexico, and the Niger River Valley in western Africa. Rift Valley lakes are also common. Examples include Lake Baikal in Siberia, Lake Superior in North America as well. The region surrounding a failed rift is often dotted with volcanoes where molten magma has reached Earth's surface. The lava erupted from these volcanoes is a combination of molten material from Earth's interior and melted silica-rich continental crust. Volcanoes that form in this manner are very explosive. Folded mountains. Convergent boundaries impose compressional forces on the rocks along the colliding plates. The rocks crumple and deform, and the pressure imposed on rocks during this deformation can result in metamorphism. These forces reshape the landscape, creating features ranging from small crinkles to massive folded mountains. Examples of folded mountains include the Andes and the Himalayan mountains. Typical structures formed in the folds of rock layers include anticlines and synclines. An anticline is a folded structure with the oldest rocks in the center of the fold. A syncline is a folded structure with the youngest rocks in the center of the fold. Fault block mountains. Fault block mountains are formed by extensional forces that identify locations where rifting is developing. The rifting may ultimately result in the formation of rift valleys and the inception of tectonic plate divergence. They often are visible along the flanks of active and failed valleys. They can also form deep in the interior of plates when hot magma in the mantle rises and causes the crust to buckle and initiate rifting. The extensional forces may originate from the movement of plates along convergent or divergent boundaries. When divergent plates move, they can cause faulting when the plate interiors resist movement because of their weight. When converging plates move, their interiors can resist movement because of the drag forces deep in the interior. In both cases, the forces break the rock into segments or blocks. If the formation of fault blocks releases sufficient pressure deep in the crust and upper mantle, igneous activity and rifting will commence. Fault blocks move vertically in relation to each other. Fault block mountains form from the blocks of crust that rise above the surrounding rock. Blocks that fall below the surrounding rock produce grabens. Fault block mountains and grabens are conspicuous features of the basin and range region of the western United States. Accreted terrains. In geology, accretion describes the process of adding rock onto crust. During subduction, a volcanic arc, seamount, or landmass on an oceanic plate may be scraped off and accrete or stick to a continental plate. The land added to the continental plate is called an accreted terrain. The accreted terrain is younger than the continental crust it attaches to. Examples of accreted terrains in the geologic record include large sections of North America west of the Rocky Mountains. At this point, you should be able to generate a full and appropriate response to today's essential question. What features in the landscape are associated with tectonic plates?